Alright, in this video I'm gonna try to go over the entire examination 5 from your booklet. It starts on page 148. This is the examination we've been working on yesterday on Sunday with the students who came to the extra sessions and today in class 2, okay? You have the answer to all of the problem. This is a detailed correction for them, okay? Alright, so let's start. Question 1. This should be pretty straightforward. You just derive right away, right? So I'm going to use a prime notation. So this is a general power rule. Here's a power down. Derive the function. Don't forget to derive the function. That's 4x. And then write the function, but reduce the power by 1. So this is it. So it should be 16x times 2x squared plus 1 cubed, and that's E, 16x 2x squared plus 1 cubed. Make sure you pay attention. Don't read it too quickly. Make sure you read carefully the answer. Okay. Second problem. All right. Well, let me write it. This one. Let me write it down. I'm looking at this integral, and it's an antiderivative, right? It's an indefinite integral antiderivative, and nothing obvious jumps to mind. What do I mean by obvious? Well, I mean, like, if you got like something like this, you know, dx, well, that's just 1/3 of x cubed plus c, you know, this is obvious. Well, nothing obvious really jumps to mind when I'm dealing with this one. So what I'm thinking about is u substitution. We've done many. Let me see. Let's try u equals x squared plus 1. And it kind of makes sense because if you derive this, you're going to find something like that, right? If this is u, that's kind of u prime. Let's see. U equals x squared plus 1. That means du is 2x dx. Okay, so we have this 2 right there. So 1/2 of du is x dx actually, okay? Okay, so let's rewrite this integral with u. So try not to mix u and x, okay? So square root of x squared plus 1, that's just square root of u. And then x dx, well, that's just 1/2 of du, right? Okay, this is not difficult. 1/2 of u to the 1/2, right? du. So let's see how it works. I need to add 1 to the power. 1/2 plus 1 is 3/2. And then I'm going to put a 2/3 right here. Got it. These two will cancel. Oh, forget the c right there, plus a constant. Never forget your constant, but it doesn't matter. This is multiple choice, right? You got to go quickly. Plus c. So it is equal to 1/3. u is x squared plus 1 to the 3/2 plus c. So I said 1/3, but I wrote 1/2. Be careful with careless mistakes on the exam. 1/3 x squared plus 1 power 3/2 plus c, that's c, right? Yeah. Okay. Number 3. Let's see number 3. So for number 3, what do we have? They are giving us, so let's write it. dy dx, I usually write it y prime when there's no confusion on what's the variable of differentiation, and it's 2xy. Okay, got it. And they want d2y dx2. Well, you know, I mean, I know what it is, right? d2y dx2, you got to derive the first derivative to find the second derivative. So let's derive that. Be careful, this is a product rule, right? u times v, there's a product right here. So u prime to v y plus u to x v prime, well, that's just y prime. So let's look at the answer. Well, it ain't there. It's not there, and the thing is, you don't have any y prime in the answer. So where's the y prime? How did they get rid of it? Well, look, here's a y prime right there. They replaced it. Y prime is 2xy, right? So let's see where we're going with that. 2y plus 2x times 2xy. So that is 2y plus 4x squared y. 2y plus 4x squared y, that's e. Okay, so right here, you haven't made a mistake. It's pretty simple, but you don't see the answer. So that means they changed it, okay? So figure out how they changed it. There was no y prime. It kind of makes sense to sub it. So how can you substitute y prime? Well, it's given with the problem. All right, let's move on. Number 4. Number 4. Okay, so what is the question about? Why is... let me read the answer because I'm not sure what they want. Increasing, decreasing, only increasing on, only decreasing on. Okay, so it's about increase and increase. So right away, I know what it's all about. If it's about increase and increase, it's about the derivative. So let me get my derivative and let me see. Now, something I've been telling you since we studied derivative is try to right away see if you can state something obvious about the sign of the derivative right away. And most of the time you won't be able to, okay? Most of the time you're gonna have to play with it and see where it's positive, see where it's negative. But in this case, it's obvious, okay? You take a square, you multiply by 6, so this is positive or equal to 0, and then you add 24. So in the end you get something strictly above 0, right? For sure. So y prime is strictly above 0. That means y is always increasing, okay? And that's A. All right, next one, 5. Number 5. Okay, f prime of 1. Oh boy, this is a piecewise function. You know what? Okay, I'll just derive both pieces there. X squared plus 2. This is a nice function, x squared plus 2. It's always differentiable. This is a nice function too, right? There's no problem with that. And this is for, of course, you shouldn't rewrite things, please, on the exam. Do not rewrite things on the exam. That would be ridiculous. I'm just detailing the correction here. So the derivative right here is 2x. The derivative right here is 2. What about if I plug x equals 1? What do I find? Well, here I find 2 and here I find 2. You know what? I'm just gonna take a stab at it and say that's C, it's 2. What am I saying here? I think it should work. I know I should be looking at the right and the left actually, okay, to do it rigorously, but I think that that result holds, and actually it does. Okay, let's move on. Okay, number 6. You got to be careful what they're asking you for number 6, okay? They want the maximum value of the first derivative, okay? So let's get the first derivative, right? The first derivative is 6x minus 3x squared. And they want the max value of this function, right? Max value. So how do you find the max value of any function? Well, you derive it. So you have to derive it again, okay? F second of x. And that's 6 minus 6x. To find the max value, I have to find the CP's. So where are my CP's? CP's is 6 minus 6x equal to 0. So x equals 1. Be careful, read the question. The question says what? What is the minimum, sorry. maximum, sorry. What is the max, not where? What's the difference between what and where? Well, if they ask you for the where, it's gonna be 1. If they ask you for the what, I don't know. I need to plug it, right? Plug it in where? I mean, sorry, it's not a play on word. Where do you plug this 1? Into the function that you're looking for the max of, right? Of which you're looking for the max. So what is that? That's f prime. So f prime at 1 is, so 6 minus 3, and that is 3, and so I'm going to say the answer is D. Be careful. You know how to answer this question. It is very easy to answer it wrongly if you don't pay attention to what they're asking you, okay? Number 7. Number 7. All right. Okay, so what's going on here? You know what? I'm going to be looking at all the statements. The first statement, actually, I don't need to look at the right side of it. You should be able to answer this question right away. What is the derivative of this? Well, that's 0, no matter what f is. Why? Why? Well, this is a definite integral. A definite integral is what? It measures an area with a sign, okay, plus or minus. So that means it's a real number. It's a real number with a plus or minus, okay? This is a real number. It's a definite integral. I have both boundaries, right? It's a definite integral. It's not an antiderivative. So if it's a definite integral and it's a real number, what do you find when you derive a real number? No matter what the real number is, you find 0. There's no variable of differentiation in the real number, right? Derivative of 5, it doesn't matter with respect to what, x, t, v, q, p, s, I mean whatever, it's 0, okay? The derivative of a real number, no matter what the variable differentiation is always 0, right? So the first one, of course, is not true. Let's look at the second one. This is a bit trickier. We have to be careful of this one. Okay, so the second one is almost correct. Almost correct. Dx equals f of x. Now, this is not true. It's almost correct. Let's try to dig a little bit into it. Okay, so you need to know that the integral and the derivative are undo what the other one does, right? If you have like d over dx of an integral, f of x dx, well, you're gonna find f of x, all right? And if you have the integral of df over dx, well, dx, I guess I guess I should use the prime notation. Let me use the prime notation here. And we don't know the variable is x, okay? F prime of x dx, well, that is kind of f of x. Actually, there's a constant there, okay? Plus c. The derivative and the integral cancel each other. The integral and the derivative cancel each other, okay? Always, they cancel each other. Okay, so when I'm looking at that, I'm like, okay, so that should be correct, right? If they cancel each other, okay, what's going on here? Let me see. Okay, here we go. So this equality should be correct, right? Because you have the you have here the antiderivative of the derivative. The antiderivative of the derivative is a function. Well, actually, this formula, you know it very well. What about if I write this? What about if, so let's look at the problem this way. I'm taking a function f, and if I derive it, I find lowercase f. This is how we looked at it, actually, okay? So now, what is the integral from a to b of f of x dx? Well, everybody knows that, right? F is an antiderivative of f, therefore it's f of b minus f of a, which, by the way, yeah, that's a good recall, we write as f of x between a and b. That's what it means, right? It means f of b minus f of a. This is just a notation. Okay, all right. So, but this is the same as that. Because what is this function? If you derive f, you find f prime. So why is this not correct? Because you don't have this on the right side. You only have the top boundary. You need minus f of 3. Okay? Now, this statement would be correct. Therefore, the given one is not correct. Okay? All right. As for the third one, that should not be a problem. The third one, if you derive, where is it? If you derive with respect to x, this function, by the way, their notation is wrong, okay? You shouldn't use the same, and so is mine then, right? Right here, this is what I wrote. You should not use the same variable for the should use t for the variable of integration and the whatever that is later boundary. Okay, all right, and this we know that to be true. This is the fundamental theorem of calculus. Okay, let's move on. What's going on with my computer here? Okay, let's see. Okay, I'm gonna ask. Oh well, here we go. Let me see. Do I have time for another one? Yeah, let's do 8. Let's do 8. We'll finish this page and I'll go to another page. So number 8. Number 8, sine of xy equals x squared, and they want dy dx, so you know what that means. That means implicit differentiation, right? Implicit differentiation. So let's do implicit. This is a sine of a function, so you have to derive the function, right? So let's derive x times y. This is a product rule. U prime v, that's y, plus uv prime x y prime, times the derivative of sine is cosine at the function yx equals the derivative of the right side is 2x. Okay, I need y prime. I know what I have to do. I have to solve for y prime. So this is y plus xy prime equals 2x divided by cosine of xy. Now, I can continue like that, but let's take a look at the answer. Let's look at what do you see? Well, none of them contain cosine. That's what they've done. It's a little trick. I mean, it's not a trick, but they went to secant. So before I go any further, let me just rewrite this line as secant, right? 2x times secant of xy. And now this is very easy to solve that for y prime. I'm going to do it directly. Y prime equals, so the first thing I do is I subtract y. The second thing I do is I divide by x. And this is e. Alright, I'll stop here the first video.